Today I am talking about lines. So, what is a line? Well, I think we all know that's a line. In math, that's a line segment because it has a beginning and an end. But what I want to know and talk about is where does this come from? I'll talk about it from the mathematical viewpoint. So in space, in space, we have three kind of things. We go along this direction, and Z. You can imagine Z basically to be the pages. It goes up and down depending on how many pages are stacked above or below. So we can pick a point anywhere, and we can kind of define that point as being at three coordinates, X, Y, and Z. And so, anywhere in space, I could be here, move over X 1 inch, 10 centimeters, or Y 1 inch, 6 inches, a millimeter, or in Z, up here, down there. Again, it doesn't matter where you start. It's just you have a starting point, and then you move some corresponding direction. So I think what we kind of learn maybe in high school is that a line, basically the shortest distance between 2 points. So we have some point here, some point there, and a line. This is an idea, right? It's not a concrete thing. It's basically what the definition of that mathematically is. But let's just forget about Z, forget about up and down, and just say we have something here. If I pick an X, maybe like call that 4. I have everything. My equation on X and Y is X equals 4, means that I can have a Y of anything. Y can be 10, can be 4, right? Anything, anywhere. But what this actually says to me, it's a line, right? What this is doing is kind of separating the space, right? We have this space, and we can call this X is less than 4, and we have all of this space, and we can call that X, anything X greater than 4. So I'm not actually trying to talk about math. That's the thing. But for me, this is kind of where I start thinking about it, because what is a line? And for me, it's separating two things. We have expressions like cross the line. It means we were here and now we are here. And there's some imaginary boundary between the two. And that's sort of what I think a line is. It's the boundary between this and that, us and them. Black and white, the usual cliches. So another sort of way to define a line is on the same plane here on this piece of paper. We can define some distance from an origin, right? Let's call that x for this case, and then we can define kind of the position, right, from some arbitrary point. And the definition of this point turns out to be like an angle, right? It doesn't really matter, right? It's not all that important. But if I have, again, x equals to 4 on this new coordinate system, I end up with all the points at a distance of 4 at any angle forming a circle. And in a way, this is also a line. Like if we look at this in math, this is the same definition I had before, right? And it's doing the same thing. You can have any y or theta or whatever, and you'll find yourself along here at some distance. And then you can also have less than 4, which is basically anything inside, and x greater than 4, which is anything outside, right? So again, it's a boundary. But sort of coming back to 3 dimensions, what we have are, let's see if I can do this in a way that makes sense. So we have a distance from an origin, and what we were defining was sort of a rotation around that axis where we have our line. But if we define sort of another rotation, we can kind of loop this around and it'll form a sphere. And this is kind of where we start getting into reality. Again, this is the same damn thing, except now we have, 2 other coordinates, one here and one kind of in a different direction, whatever, right? And again, the same thing, anything less than 4. I don't know why I picked 4, maybe it's my favorite number. Anything less than 4, inside of it, anything greater than is outside. So now we have this object, and what this is defining is a surface. And what I'm trying to say is that this line that we draw so easily comes, I think, comes from the distinction between a surface. Like it's representing a surface, and that the surface divides, this from that, one thing from another. So again, this surface, if we can have other shapes, we can have my favorite blobs, right? And it can be sort of any shape, but a real object like an orange or nickel or something is like it's a closed surface. It's an envelope, like a bubble that's kind of sucked in everywhere, and you can travel kind of along this point and reach the other side or whatever, but things are just one surface. in general, right? That's how we define an object, right? It has a singular thing, and we know there's two because there's multiple surfaces, right? And in life, these surfaces kind of, you know, sometimes they're squishy, right? You know, poke the skin, it's squishy, but it's still a surface. And what we see is sort of this surface. When we draw an outline, it's a 2D representation of the separation between this object and the rest of the universe. And that's kind of where I think lines are coming from, right? So you might ask, when I draw, sometimes we don't have an enclosed thing. What then, you ask, the hell is happening here, right? So my sort of thinking is that we have this, and what this open kind of area is saying to me is that this bit is a protrusion from the rest of it. This is where our thing, our nub, connects to the rest of an object. It's probably an object, right? Sitting there. So I was thinking about this again, and I like cutouts apparently. So I made some cutouts just so I could think about lines and objects, and I made just blobs basically, and we think about another line on top of it, and this is an object, right? This is in front, now it's behind. I had drawn this on some of these with an open edge, right? So you can see, like by itself, that's okay. It's a C or D, something, right? By itself, kind of nothing. But you put it on here, and hello, it suddenly becomes a nose. And maybe we have an eye and another eye kind of poking off the side, or it's a mouth, whatever, right? So to me, this, because it's a circle, it's somehow separated from our bigger object, but it connects, right? Like if I look at the top of something and then kind of rotate it around, what I might be seeing is this, right? Or if I see this, again, these might be the same thing, but we're working in like 2 dimensions when we draw, and I think I'm gonna be done talking about just straight lines, although all of these are curved. What I want to sort of discuss briefly, because I'm running out of time, is thickness. You know, in reality, a surface is just an imaginary thing. But it represents the point at which something changes into something else, right? So when we draw, uh, we when I use lines, we use a variety of line thicknesses, which doesn't make sense mathematically, but in another way, it kind of does make sense. We can see the outside outline. That's the distinction between the universe and the ball. And then this inside bit, it's sort of different. It's distinguishing not matter, not the physical object, but it's distinguishing between the light in that part and then the darkness where the shadow is. So that's sort of one role of line thickness. And another role, I think, is again to highlight contrasts, right? So if I have something in the background, it may have a thinner, less bold line. And that, to me, says that this bold line means that this is closer, because the distance from here to some arbitrary background is larger than the distance from that background to this other object. That's not quite clear. And that's sort of it. I think I spent a lot of time thinking about this, and it seems pretty short, that I didn't really explain much, but it's to me, it's kind of the origin of lines in drawing, which is important to me because I draw. And I think I'm done here. I hope these are useful or interesting to someone somewhere.